You know, for over a century, we've been wrestling with the biggest questions about our universe. We've come up with these incredible theories, right? One for the vast cosmic scale, and another for the truly bizarre world of the super small. But what if the real mystery isn't what these theories say, but why they just don't seem to get along? That's the giant puzzle we're going to try and unpack today.
But hey, before we dive into galaxies and atoms, let me ask you something a bit more personal. When you look at the world, when you observe something, do you feel like a totally separate person looking at some external thing? Just hold that thought, okay? Because it's right at the heart of everything we're about to get into.
All right, so to get where we're headed, we got to start with where we are right now. And in modern physics, that means we're dealing with two amazing, powerful, but fundamentally conflicting stories about what reality even is.
On one side, you've got Einstein's general relativity. It's beautiful, it's elegant. It describes the whole cosmic dance of stars and galaxies as this smooth, predictable system. But then, on the other side, you've got quantum mechanics. These are the rules for the teeny tiny world of atoms and particles. And that world, well, it's just plain weird. It's all about probabilities, uncertainty, things being in many places at once. And the big problem? These two rule books, they just don't play nice together at all. This clash has been the biggest headache in physics for decades. But what if the problem isn't with reality itself? What if the problem is that we think they're two different things? What if we've been trying to read two separate chapters of a book without realizing they're actually telling one single unified story?
So, this is where a really powerful idea comes into play. It suggests that instead of seeing a universe full of separate things, stars over here, atoms over there, we should try to imagine it all as one single, seamless, interconnected fabric.
The core concept we're digging into is this idea of a deforming fabric. And the proposal is that everything, and I mean everything, from energy and matter to space and time itself, is all just a different shape or a different ripple in one single indivisible, constantly changing whole. So it's not a universe of separate objects. It's a universe that is just one continuous thing.
And you know what? This connects perfectly with something we already know from Einstein. We've all heard that big things like planets and stars warp spacetime, and we feel that warp as gravity. Well, this idea takes that a step further. It says the reason energy deforms spacetime is because energy is a deformation of this one underlying fabric. Gravity isn't some mysterious force acting on things, it's just the actual shape of the fabric itself.
Okay, so if this fabric idea can handle the big cosmic stuff, how on earth does it explain the absolutely bizarre world of the very small? Well, this is where things get really wild, and it's going to challenge some of our most basic ideas about how we see the world.
Okay, get ready for this, because this is the most radical claim we're looking at. For 100 years, physicists have been arguing about how to interpret quantum mechanics. What does it all mean? This idea just flips the whole table. It suggests quantum mechanics isn't some deep truth about reality that we need to explain. No, it is the explanation for what happens when we try to slice up something that can't be sliced.
I mean, really let that sink in. All the weirdness of the quantum world, the randomness, the uncertainty, it isn't a fundamental feature of reality. It's what happens because of our assumptions. It only pops into existence when we, the observers, decide to draw a line in the sand and say, okay, this is a particle and that over there is my measuring device. And because, in reality, that line doesn't actually exist, nature it protests.
So how do we create this illusion? It's basically a trick we play on ourselves, and it happens in a few steps. First, we start with the one, whole, unbroken fabric. Then, in our minds, we impose a division. We carve out a piece and we label it particle. Then, we label another chunk apparatus. The very second we make that artificial split, boom, nature protests. And all those weird quantum effects we see, that's the protest. That's the result of trying to split the unsplittable.
And suddenly, this explains so much of the quantum weirdness. Why is a particle's location just a probability until we look? Because by looking, we're forcing artificial separation onto a single system. And entanglement? Where two particles seem magically linked across huge distances? Well, why does that exist? Because they were never really two separate particles in the first place. They are, and always have been, connected parts of the same whole.
And you know what else this does? It offers a brilliant way out of another huge quantum puzzle, the so-called collapse of the wave function. That's the idea that a particle is in a haze of possibilities until we measure it, and then it suddenly collapses into one reality. But from this fabric perspective, you don't need a collapse. There's nothing to collapse, because the entire system, the particle, the machine, the environment, you, me, everything, was already one completely interconnected or entangled whole from the very beginning.
So all of this, it leads us to one final and honestly pretty profound conclusion. One that takes us right back to that question I asked you at the very beginning. If the observer and the thing being observed are actually part of the same fabric, what does that mean for us?
The whole act of measurement gets a major rethink. It's no longer a scientist in a lab coat standing separate from the experiment, poking at reality. It is, quite literally, one part of reality interacting with another part of reality. It's the universe measuring itself. It's deforming fabric, measuring other deforming fabric.
And who is it that's doing all this interpreting? Who's the one drawing the lines and sticking on the labels? Well, according to this idea, it's us. We aren't outside observers looking in. We are a piece of the deforming fabric that has, through billions of years of evolution, developed enough awareness to look back at the whole and try to figure itself out. So, let's end this right back where we started. If you, the person watching this, are not separate from the world you see, if you are fundamentally part of the same indivisible fabric as the stars, the atoms, and the screen you're looking at, then what are you really measuring when you do an experiment? Maybe you're not just measuring the universe. Maybe you're the universe measuring itself.